This video is all about pitch class and an intro into set theory. Specifically, we're going to look at Stravinsky and the Rite of Spring in this video. Okay, so this is basically an intro into what will eventually be set theory. Okay, so first, a few things that you need to know. Okay, so we think of pitch as like a specific frequency, right? So for example, C4, middle C, is different than C5, right? And you can hear the difference, right? Here's middle C, here's C5. Right? So they're technically different pitches, right? Different notes on the page, different frequencies too, right? Pitch class, though, is going to consider those C's as basically just the same thing because they're both C, okay? So when we talk about pitch class, we assume that all pitches have what we call an octave equivalence, okay? And if you think about it, this kind of theory would not have existed if we didn't have equal temperament, right? But because of that, we can use that theory like this. So in other words, middle C and C5, so the octave higher than it, they're all C's. Okay, so when we talk about pitch class, we don't consider them to be different. Okay, same thing if it's like an enharmonic note. So D sharp and E flat are not going to be considered different. Okay, they're the same note. Okay, even though, yes, they would look different on the page and they would probably have a slightly different tuning, right? If you were playing something other than the piano. Okay, so a pitch class set is just a grouping of these pitches in a set, okay? And the way that we do it is we put all of these notes in the most compact form, and so they all have to be within a single octave, okay? So that's why pitch class is going to be important, and it doesn't matter what octave that note sounds in. When we put them all into a set, when we put them all together, we're just going to put them as close together as possible, basically, okay? So our first pitch is going to be what we call zero, okay? It's ground zero for our set. And each semitone is going to equal just one, okay? I'll show you what this will all mean here in a second. So prime form for set is going to mean the smallest intervals are to the left. Okay, so let me show you what this means in practice, basically. Okay, so this is actually some notes from Debussy's The Second Cathedral, which we'll look at before we get to Stravinsky's Rite of Spring. Okay, so if you look at this first one, this is the notes that we get in measure one. Okay, so if you notice, they're not all like as close together as possible, right? So when we put them into their own set, when we group them together, we're going to put them as close as possible. So one thing that we're going to do is we're going to put this B down closer. Okay, so right here, you can see we actually shifted that B down an octave. Okay, doesn't really matter though because it's still a B and it has octave equivalence, right? Okay, so now if you look at these numbers underneath, this is how we got them. So the B is 0, okay, so the starting note, so we don't put a number on it, okay. Then we just count the number of semitones between that B and D. So if we're starting on B, we have 1, 2, 3. So there are 3 semitones to get up to D, okay. And then we keep counting to get to the last note, okay. So the last note doesn't go from like D to E. We're going from B to E to get this number, okay. So we already had 3. Then if we keep counting up, so here's 3 on the D, so 4, 5. Okay. So there are 5 semitone difference between B and E. Okay. Now this is not actually prime form because, and you'll see it right here, this one is basically what we consider the inversion of this one, right? The easiest way to think about the inversion is just think of it backwards, okay? So right here, if you think backwards, so starting on E is 0, okay? And then if you count semitones, so here's our 0 note. So 1, 2 to get to D, and then 1, 2, or sorry, 3, 4, 5 to get to the B, okay? So then in order of like gradually increasing numbers, 0 to 5, okay? Now these are the same sets as what we would consider them, but this 0 to 5 is what we would call prime form because it has the smallest numbers in it. Okay, or in other words, if you added all of these numbers up, this one would be smallest, right? It has, and it would have the smallest intervals to the left. Okay, so specifically what you want is smaller numbers to the left of the set. Okay, so once you got 0, 3, 5, you would also want to think backwards to see if 0, 3, 5 was prime form, or if the backwards version 0, 2, 5 was smaller. So it's 0, 2, 5 in this case. Okay, more examples. So if you look right here, okay, we're going to take these first 3 notes. So we're working with just 3 notes right now. Okay, you can have sets of more than just 3 notes. Okay, but right now we're just going to work with 3. So right here, they put it down here just so that we don't have to read so many ledger lines, right? So we've got C sharp, D sharp, and E. Okay, notice we didn't take the order of these notes right here, right? If you look at this set over here, it's out of order technically compared to how the notes appear, right? But we're just trying to put them in the most compact form possible, okay? And they're always going to be like ascending order too, okay? So the smallest space is to put C sharp on the bottom right, and then E on the top, and then we just put that D sharp in the middle, okay? All right, if you were counting like up these notes, so the C sharp would be 0, right? And then we'd have 1, 2 semitones. So it'd be 0, 2 right here, and then 3 right here. Okay. So the way that this one is actually written out from like bottom to top is actually 0, 2, 3. But if you go backwards, it's 0, 1, 3. That one's just slightly smaller than having a 2, right? So the prime form of this one is 0, 1, 3. Okay. Now the next set that we're going to look at is the C sharp to D sharp to G sharp. So we just kept it right here. If you reordered it, so in other words, if you put the G sharp down here, for instance, so let's say we put G sharp right here and then went C sharp, D sharp, right? It would not be prime form because if you think, I'm just going to put my spotlight where G sharp would be, okay? They would both have a span of a perfect fifth, right? So G sharp to D sharp is a perfect fifth versus the way it is right now, C sharp to G sharp, also a perfect fifth, right? But if we did G sharp to C sharp to D sharp, I don't have the smaller intervals to the left, right? Versus this one, I have the smaller intervals on the left-hand side, okay? If you had done it this way and thought about it like backwards, then you would have ended up with this too. So it wouldn't have been necessarily too much of a problem, okay? Okay, so 0 to 7 comes from just the number of semitones. So 0 for our starting note, then D sharp is 2 semitones away, and then 7 is how many semitones you get if you count from the C sharp to G sharp. So it's a perfect fifth, and that's 7 semitones. Okay. Okay, so if you look at this one right here, this G sharp and F sharp are repeated notes from over here, right? So we don't consider these for our set class because we've already got those notes. Okay, so this D sharp though is pretty far away, right? So if we just put it down closer to these other notes, then we end up with this, right? So if you're counting these notes though, so D sharp is 0, right? And then F sharp, 1, 2, 3, right? And then if you count up, 4, 5, okay? Notice they did not label it 0, 3, 5 because that's not the smallest version possible. So they went backwards, right? So the backwards version or the inversion of it is what's smaller. So 0 right here, right? And then 2 semitones right here, and still 5. Okay, the outer number should never change if you're doing it like up or down. They're both going to be the same. So you might have, oops, sorry. Let's go backwards. I wasn't ready to go on. I bumped it. Okay, so if you've noticed, just looking through what we've got so far, this one was 0, 2, 5. This is all coming from the same piece. And this one was also 0, 2, 5, right? We have the numbers 0 to 7 up here, and we're going to get them again down here. And that number looks familiar too, right? We've had that 0 to 5 before, right? So set theory is a way to show basically like a motivic relationship between notes when we aren't necessarily in like tonality, okay? So this can be used in pieces that are still using tonality, okay, that still have tonal centers. You can also use set theory though for pieces that are atonal, so that don't have tonal centers anymore. Okay, now let's get to Stravinsky, okay? All right, here's all the themes basically for Stravinsky's Rite of Spring, okay? You're probably pretty familiar with all of these already, okay? But we're going to look at all of these and basically apply that set theory to these so that we can see the relationship, because this is a motive that is basically developed, but you don't necessarily see it immediately because for one, they're not all going to start on the same note, right? They might be transposed. They all have different rhythms, right? The rhythms are not all the same. They also aren't even necessarily always in the same meter, right? Different meters. They might also have different placements on the beat, right? We get metric displacements on some of these as well, okay? All right, so we're going to start though with some of the smaller themes first, okay? So I'm gonna start with theme C. So we've got, okay, so if we took all of the notes, okay, there's really only 4, right? So we have a C sharp and an F sharp. So we've got C sharp and F sharp down there. We also have a D sharp right here, right? We also have a G sharp right here too, okay? And if you look through it, it looks pretty close, right? I could have done this in a different order, right? And let me show you. So we've got C sharp, D sharp, F sharp, G sharp. So if I had done it in a different order, let's say I started with F sharp, okay? So we're gonna do F sharp and G sharp, and then let's say I wrote down D sharp next. And then let's go up to, oh, let's say though that I even wrote it out even weirder. Oops, right there. Okay. First thing you want to do is put them all like closer, right? I guess I could have done this even weirder, right? Like this, for instance. Okay. Okay. So you might see something that looks more like that, right? So first step would be to get them all in the same octave, right? Okay. So if you wanted them on the same octave, looks like a lot of them are down here, right? So then we drag that one down. And then you might notice, oh, that one's got a lot of space, right? So then you could put this one down here as well. Whoops, there we go. Oops, not that. Wrong note highlighted. Okay, this one's not in order though, right? So you might have also thought to yourself, oh, okay, well, if I put it up like this, it's still the same octave, right? Like this. Okay, still not the same or not all in order, right? So we could swap places with the C sharp and D sharp. Hopefully you're seeing how complicated it is to do it this way. This is like doing all the steps to a math equation when you could leave out some steps. Okay, so if you look through this one, notice it's got a pretty big gap right here, right? When you see a bigger gap, that's usually telling you that this note that's on top of like the bigger gap should actually be like the lowest note for your set, okay? So if we do it over here and leave that C sharp as the lowest note, then we get this, okay? If you still weren't certain, you could start the set on each different note and just kind of go up and see, okay, which one has the smallest outer interval? Because you need the smallest outer interval first, okay? Okay, so this one gives us our smallest outer interval like this, okay? If you look down, oh, it's showing up right here in green. It's kind of unhelpful, okay? But if you look right here, so we're going to call this C sharp 0, right? And then up 1, 2. So D sharp is 2. and then 3, 4, 5. So F sharp is 5, and then 6, 7, G sharp is 7. Okay, so the numbers right here, 0, 2, 5, 7. Okay, I'll put that in so that you just know. Okay, here's 0, here's 2, here's 5, here's 7. Okay, now we'd have to check though and make sure that that one's the prime form. So we have to check and make sure that like backwards isn't smaller. Okay, or you could invert it. I'll show you what it would look like inverted here in a second, just to show you the long way. Okay, so if we start on the G sharp and go backwards, then we have G sharp is 0, 1, 2. So F sharp would be 2. Then 3, 4, 5. So D sharp is 5, 6, 7. We had the same numbers, right? Yeah, Stravinsky is tricky, clever like that, really. Okay, so yeah, this one is the same, whether it's like it's normal theme, normal order, or going backwards, so inverting it. Okay, all right. Let's say that I wasn't convinced that just counting backwards is the inversion. I'll prove it to you. Okay. All right. Okay. So here's our C sharp. Okay. Now we just have to invert everything. So instead of going up 2 semitones, we're going to go down 2 semitones. So we would be on B, right? And then we're going to go down another 3 to make it 5, right? So here's the C sharp, and then we went 1, 2 to get to B. And then 3, 4, 5 would give us G sharp. G sharp. Okay, and then we're going to add 2 more, or 6, 7, right? So that would give us F sharp. F sharp. Okay, now you notice this one's not in like ascending order, right? So when you count it, you would technically have to think this way. G sharp, B, C sharp. Okay. So now starting on that F sharp and counting up. Okay, so we've got F sharp is 0, and then 1, 2 is G sharp, and then 3, 4, 5 is B, and then 6, 7. So we get the same theme, right? All right, so that's why just counting backwards is going to just be your trick. It's the easier way to figure out the inversion. Okay, it's just thinking through your set but backwards. Okay, or you can invert the whole thing and then reorder it so it's going up, or you could just count backwards on the inversion 1, 2. But that's the long way. You don't need to do the long way. Okay, all right. So all of that was just to show you how we got to this 0, 2, 5, 7 set. Okay, that was a really long-winded version, but hopefully that makes more sense now, how we got that. Okay, now we're gonna look at a different one. Okay, so this is theme D. Okay, so it starts clear up on that D sharp, so. Okay, now this one is kind of all over the place as far as octave, right? Like what register all of these notes are in. Okay, so you'd first have to get them all next together. Okay, now even just looking at this, you can see like these notes are kind of close together, right? And these ones are kind of outliers, right? The A sharp though is the same as this A sharp, so we wouldn't need to like repeat it. That C sharp is the same as that C sharp when we consider pitch class, right? So we just need to get that D sharp closer to this grouping of notes down here, right? And the closest D sharp to any of these notes is this D sharp right here, okay? So that's how we come up with this set right here, okay? You could just get them all in the same octave, and then if you saw, oh, I've got a big interval somewhere, then the top of that big interval should probably be note 0, right? Should be the starting note, okay? You could reorder these, right? You could say like A sharp, C sharp, D sharp, and then G sharp up here, but that would give you a far larger interval, right? You could also start on C sharp, so it'd be C sharp, D sharp, and then G sharp and A sharp, but then you would have a larger interval too. We just have a perfect fifth right now. If you went C sharp, D sharp, G sharp, and A sharp, then you'd have a major 6 on the outside, okay? Anyway, so on and so forth. Okay, you could also do it on D sharp, but then you'd have a 7th. It would be much larger. Okay, all right. This one is also 0, 2, 5, 7. Ooh, you might be seeing the theme here, right? Yes, this is It's the same motivic relationship. But if you heard this one and just thought back to the other one, they don't really sound the same, right? Because the rhythm is completely different. The way that he repeats some notes and doesn't repeat others, it's all completely different. But the pitch class themselves, the set of pitches, is actually the same. Okay, so if you don't believe me yet, G sharp would be 0, right? Then up 2 semitones gives us A sharp. So here's G sharp, 1, 2, and then 3, 4, 5 is C sharp, and then 6, 7 is D sharp. All right. All right, theme E sounds like this. Okay, we're going to look at basically just E1. Okay, the other one is the same. It's the it's the same notes. Okay, but almost like an inversion if you look at the way that he treats it, right? Like this one starts out high, goes down, then up. This one starts like lower compared to the other notes, and then it goes up, and then it goes down, right? So they're almost like flipped versions of each other. Not quite, but all right. So if you looked at this one, you could have put this together in several different ways, right? You could have started on this F right here, and then put in your B flat, and then your C, and then your E flat. But then you might notice, oh, I've got a pretty big gap between F and B flat, right? And that would tell you, okay, maybe I should start this on B flat instead. So you'd have B flat, the C from over here, E flat, and F. Okay, so that's how it came to this one. Okay, so this gives us the smallest interval on like the outside. Okay, also gives us the smallest intervals to the left too. Okay, so we want smaller numbers on the left side too. Okay, this one is again 0, 2, 5, 7. Okay, if we went up and counted, it'd be 0, 2, 5, 7. If we went backwards, so thought from F is 0 and then down, it's also 0, 2, 5, 7. Okay, so cool. I'm sure he knew that these are all 0, 2, 5, 7s, right? That doesn't just happen by coincidence. Okay. All right, so theme B sounds like this. Okay, doesn't really sound like any of the other themes, but none of them have really sounded that similar, but we've discovered that they are. Okay, so this one has more notes, right? We have a B. We have, if you just went up from B, okay, because B was lowest, we also have a C sharp. We have a D, we have a D sharp, we have an E, and we have an F sharp too. So it's almost a chromatic scale, but just skipping some notes, right? So it sounds like this. Okay, so basically we just skip C and then an F natural. Okay. All right, this one doesn't have any like big intervals anywhere, right? If you ordered it like this, but you could test and make sure that this was the smallest and most compact version by starting it on different notes, right? But if you started on C sharp, you'd have B up here. That would give you a 7th, so not smaller. If you started it on D, then your top note would be C sharp. So that would be a major 7, not smaller, right? So on and so forth. Okay, so this is the smallest version. Okay. All right, so if we count from here to label our set, B is 0, and then we go up 1, 2. So 1, 2 to C sharp, and then we just have semitones. So now it's 3 for D, and then 4, 5. Sorry, I'm trying to point at that with my left hand. And then we skip over the F, which would be 6. So then this one is 7. Okay. Now you notice this one has some of the same numbers we've been seeing, right? We have 0 and 2 still, and then 5 and 7. It's basically like he just filled in this gap between 2 and 5 with like a chromatic scale, so all semitones. So yeah, it's pretty related to all the other sets that we have seen up to this point. Cool. Okay. Now, A, okay, you might have noticed that we have not gone in order, right? It's because A is the most complicated, okay? So we built up to it. Okay, here's A. Here's what the whole thing sounds like. You will definitely recognize it. All right. Okay, so if you look through here, this first one right here, okay, it's showing you this set. Okay, so we have a C. If it helps, you could even just start, when you're trying to put these on the same octave, you could even start with like middle C or whatever. So that's what I did right here. So I have middle C, and then just go up and see what you have. Okay. So you'd look through, see if you have any C sharps or D flats. We don't. We have a D right here. Right? So the D came from right here. Okay. And then we don't have a D sharp or E flat anywhere, but we do have an E. We have several E's, right? We have an E here and here and here, right? So we have this E right here, okay? And then we don't have any F's of any kind. So we don't have an F or an F sharp, or in other words, G flat, right? But this was all white keys anyway, okay? We do have a G, so we have several G's, one there, one here, one there. And we also have A's. You can see there's the first A. We get more A's right there. And we also have a B. Okay. Okay. Now, if you look through this one, C, D, E, F, A, B, there's not necessarily any like humongous gap anywhere, but we do have a major seventh interval, right? From C to B. So likely that isn't our smallest, most compact version. Okay, so there is a little bit of a jump right here. Okay, that's our biggest interval. So let's try starting our set on G instead. So if you look over here, that's what I did. So I reordered it on G. Okay, so I have G, A, B, C, D, E, right? It's just going up a scale basically, but missing the F. Okay, all right. So the numbers that we get for this set over here. Okay, so if you start on G, we go up. So 1, 2 is on A, and then 3, 4 is B, and then 5 is C, and then 6, 7 is on D, and then 8, 9 is E. Okay. Okay. And that's our prime form. You can check it backwards too if you really want to, but okay. So this one is actually like 3 overlapping sets of 0, 2, 5, 7. Okay. So it's pretty cool. So if you look, I will, like circle them. Oh, be easier to do it like this. Okay, so we can do it right here. Here's 0, here's 2, and then let's see, 5 is right here, and then 7. So 0, 2, 5, 7. Okay, that's the first like 0, 2, 5, 7 set. Okay, okay, let me erase those now. Okay, here's the next one. Okay, it will maybe not look quite the same. Okay, I'm going to circle them first, and then we're going to count just so that you can see it really is 0, 2, 5, 7. Okay, so if you looked at just these notes, so A, B, D, and E, so let's just count the numbers between those. So now we're going to pretend that A is 0, okay, and then 1, 2 for B, 3, 4, 5 is D, and then 6, 7. So that's actually a 0, 2, 5, 7 as set as well. Cool, right? Okay, next one. You kind of have to think differently. So, okay, 7, 9, 0, 2. It's these ones. 7, 9, 0, 2. So in your head, think like this. It'll be D, E, G, A, so higher, okay? So imagine after this D and E, that G and A are written up above it, okay? Or alternatively, you can think D and E are written down here lower or before G and A, okay? All right, so starting on D is 0. So 1, 2 is E, 3, 4, 5 is G, and then 6, 7 is A. So another 0, 2, 5, 7 sets. Very cool, right? At least I think it's cool. Hopefully you think it's cool too. Okay. Okay, so some other things that happen in Stravinsky's Rite of Spring that are worth noting. Okay, these are some more compositional techniques that especially Stravinsky uses, but other composers in the 20th century also use them. Okay, so one is called stratification. Okay, So that just means layering in a nutshell. Okay, so you have different lines and like different texture things that you can see. Um, and they're all presented at the same time, and they're all clearly audible, but they're all very separate. Okay, so it's not like they all belong to the same chord or anything. Okay, so it's several things happening at the same time that are completely different. Okay, it's like if you're in a practice room, you might hear someone next to you, like a trumpet, playing their pieces, right? But you might also hear a vocalist in the room next to you, right? So different things that are happening at the same time. Okay. It's not necessarily always that extreme, but sometimes it is. Okay. If you look at like Charles Ives, sometimes it is kind of extreme differences. Okay. Juxtaposition, okay, means that all of a sudden you get this interruption, okay, and then while you get this interruption of what has been happening, you get a different texture or a different idea all of a sudden, okay, and then it goes back to the previous theme, okay, so you're going along with this idea, and then it's like it stops. It has, if you've seen like Up, the dog Doug on there, right? He's like going along, and then all of a sudden he's like, oh, squirrel. And then he goes back to what he was doing before, right? It's kind of like that, okay? So the other way of describing it, the music is interrupted, right? And then it continues after that interruption, okay? It continues on with the initial idea, okay? All right. Synthesis means that all of this different stuff that's been happening comes back at the end as a way of unifying the piece. Okay. Polycentricity, or in other words, polytonality, we kind of talked about in a different video. That means that you have multiple tonal centers all at the same time. Okay. Another thing that Stravinsky really loves doing is meter changes or mixed meters. So you might be in 4/4 for one measure, and then he might change to like 7/8 and for a measure or two, or however long, and then he switches to 3/8, and then back to 4/4, and then 3/4. Or okay, so all of that is mixed meter. Okay. Not the same as polyrhythm. Okay, polyrhythm means that you have different layers that all have a different subdivision of the beat. Okay, so another way of putting that, it's easiest to think about it in terms of like an orchestra. Okay, so let's pretend you have an orchestra and the violins are playing eighth notes. Okay, so violins are playing eighth notes, but at the same time, the flutes are playing triplets. Okay, so they have two different rhythms, right? Two different subdivisions, because if you're doing eighth notes, it's 1 and 2 and, right? But if you're doing triplets, it's 1 and 2 and, right? You can be even more extreme, right? You might have another section, maybe the brass is playing septuplets, right? They're playing 7 notes at a time. That seems unlikely for brass. I probably could have given them a more realistic rhythm, but anyway, that's the idea, okay? Polymeter is a little different. Okay, so polymeter means that at the same time people are playing in a different time signature, basically. Okay, so maybe one section of the orchestra, like the violins or something, or the strings, could be playing in 3/4. Okay, but at the same time the brass is playing in 4/4 or something else. Okay, yes, so all of this, though, it's all kind of related to even that very first theme, right, of stratification. So you have that layering kind of effect where you have multiple different layers and they're all doing something different. So whether it's a different idea, different texture, different tonality, different rhythm, different meter, okay, all of that could be a way to make your harmonic language interesting, right? And your compositional language interesting in a 20th century kind of way. Okay. All right, I believe that's the last slide. All right, so that is it for this video, specifically Stravinsky and your first taste of set theory. There will be much more on that later though.